A lot of the settings and features in Bambu Studio are hidden unless you activate advanced mode. In this video, I'm going to be going through all of those settings and features, letting you know what they are and how to use them. I've already published a Bambu Studio beginners tutorial in which I go through all of the settings and features that are available in Bambu Studio as standard, as well as explaining everything you need to know to get yourself 3D printing. If you haven't seen that and you're either new to Bambu Studio or 3D printing in general, make sure you check that out before you watch this one. I'll leave a link in the description below. If you are ready to get started with Bambu Studio Advanced Mode, grab yourself a coffee and let's get started. So to activate Advanced Mode, you may have noticed the Advanced switch on the left next to the process settings here. But we're not starting with the process settings, we're starting with the printer settings. There isn't a tab up here, but if you go to the Edit Presets next to your selected printer, you'll notice that there is an Advanced switch here as well. This is a universal switch, so when you activate it in one place, it activates Advanced Mode for the entire slicer. For the most part, you're only really going to need to change these settings in the printer settings section if either when you were first setting up your printer, it wasn't available in the list of presets in the configuration wizard, or at a later stage you have heavily modified your printer and changed what your printer is physically capable of. As a result, whilst I will be doing an overview of all the features in this printer settings section right now, I'm not going to go into too much detail as I will be covering them in a feature-specific video at a future date. The first option here is the Change Printable Area section. If you click on here, it allows you to define the area available for 3D printing. The one below this, Exclude Bed Area, is kind of the opposite. It allows you to define areas that you are not able to place items for printing. As I have a Bambu Labs X1C selected, by default the area down here is excluded as this is where the printer goes to cut the filament when doing a filament change, and if you were printing in this area it could result in stringing or damage of your print. If you needed to print with absolute maximum volume on an X1C, you could just come here, delete the coordinates here, and then you'd be able to add models to this area without warnings. But now I'll just click the orange arrow here, that will reset its default, and you can see that it has added the exclusion area back onto the print plate. Next up is the printable height, and this is the physical capabilities of your printer, how high it's capable of printing. This isn't something that you're going to be changing generally unless you physically change the capabilities of your printer by changing the Z-axis bars. Next is the nozzle volume, which is the volume of filament which can live between the extruder motor and the point that the filament is being extruded out the end of the nozzle. This is not something that you are generally going to need to change for your printer unless you're heavily modifying it. The best object position is effectively coordinates of where it will automatically try and place your objects as close as possible to when you're using the auto layout buttons. By standard it's at 0.5 X and Y, which means it's trying to place it in the center. If we adjusted this, let's say 0.7 and 0.3, just to show you something different, if we then hit the auto layout button, it's trying to put it down in this new position. This could be useful if you've got a dent or something on your print bed and you want to be able to use the auto layout button without it placing everything on some damaged area towards the center of your print bed. The rest of the settings here in the Basic Information tab under Advanced and Extruder Clearance are only really relevant if you're heavily modifying your printer, for example changing the length of the rods or the type of G-code that your printer is going to recognize. Let's move over to the Machine G-code tab, and this is divided into several sections. You've got Machine Start G-code, Machine End G-code, and the list goes on. Effectively, this is where you can put G-code scripts which will run automatically at specific points in your print, and you can put them here to run on every print you export. I do plan to do a G-code masterclass so you can learn how to read, write, and edit G-code yourself, but for now this isn't something that you need to worry about or change. The next tab is Motion Ability, and this is specifically looking at the physical capabilities of your printer, specifically the motors and motor controllers. So this isn't something that you're going to need to change unless you physically change the type of motors or motor controllers in your printer and adjust what speeds and accelerations it's capable of achieving. And then we move on to the final tab, Extruder. The first section we have here is Type with the option Type. This is referring to the position of the extruder motor. The direct drive that we've got set here is where the motor sits right with the hot end and the nozzle and is pulling the filament towards the hot end and nozzle. The alternative would be a Bowden drive, where it sits either above or outside the printer and it pushes the filament along a PTFE Bowden tube towards the hot end and the nozzle. Speaking of the nozzle, the next setting we have here is the nozzle diameter. This is something that you might want to change from time to time. Even though the default is 0.4mm diameter, you might want to switch down to a 0.2mm to be able to print in finer detail, or go up to a 0.6 or 0.8mm diameter to print faster. I've got a number of videos coming very soon looking specifically at the advantages and challenges involved in swapping out your nozzle, so keep an eye out for them. The next section, layer height limit, really refers to how detailed the motors in your printer can be. So here we've got the minimum and maximum layer heights that you are able to set over here. And this is basically defined by how accurate your motors can be. This printer is capable of reliably achieving a layer height of 0.08mm when using a 0.4mm nozzle, so that is what has been set here. This is something that you're not going to really need to change if your printer was listed in the presets in the setup wizard. By the same token, the extruder offset section isn't something that you're likely going to need to change, but this is effectively the relative position of the extruder nozzle compared to where it thinks it is. And now we have retraction. I did actually mention retraction in the beginner's tutorial a bit, but we'll go through some of these settings now. Retraction is basically any point in the print where the printer needs to stop extruding and move the nozzle to a different point. It retracts. What this means is it will draw a length of filament back into the nozzle, either lift the nozzle or drop the bed depending on the design of your printer, move to the new location and then start printing again. These settings control how this happens. The length refers to the length of filament that is drawn back into the nozzle when it retracts. The Z-hop is the distance that the nozzle is raised or the bed is dropped. And the Z-hop type is the shape that it follows when it's doing the Z-hop. All of these settings, including the speed, affect how this process happens, and I am going to be doing a retraction specific video at a future date. Again, these settings aren't something you'll generally need to worry about unless you're having real issues with stringing and oozing, in which case these are one of the settings that you want to check. Now let's move on to the filament settings. You'll notice again there is no advanced switch on the filament bar, but if we go into the edit presets button on one of our filaments, you'll notice that it is located at the top right here. The first thing we have here is type or material type. This was available without the advanced switch, but beneath that is vendor. I think the reason that vendor was hidden under the advanced switch is when you're just starting out, it's easier just to see filaments by their material type, PLA or PETG or ABS. But the same material from different vendors can also have different properties, such as require different melting temperatures or have a different density. As a result, it's good to have different presets for each material type from each individual vendor you buy from. The default color refers to the color that will automatically be selected when you select this filament preset. The alternative is to leave it as it is with this red stripe, which means no default color. With no default color selected, if you went and changed one of the filament presets to a different preset, it's not going to change the color that was already selected. If you were to set a default color, then every time you switch to that preset, that color would be selected. But you could still then go and just change the color by clicking on the color box next to the filament. I covered the diameter in the basics tutorial, and this is just the diameter of the filament that you're feeding into your 3D printer. With most FDM 3D printers these days, this is 1.75mm. The flow ratio adjusts the extrusion rate based on the volumetric change of the filament from solid to molten state. This will usually be between 0.95 and 1.05, but can vary within a material type from vendor to vendor. Vendors should specify a rating for this on the product page on their website, but if you can't find one, just leave this as 0.98. The filament density can also vary depending on the vendor, but they often will also share these details on the product page. This figure, however, is primarily used in Bambu Studio for calculating statistics like the length of filament that will be used based on the volume of plastic it's required to print. By adding the price that you're paying for a kilo of this filament here, when you slice your model, Bambu Studio will tell you how much you're paying for this print based on the amount of material it's planning to use. The filament and nozzle temperatures were covered in my Bambu Studio Basics tutorial, but these are among the most important settings in the filament section. Again, these will not just vary by material type, but also vendor. so try to use the figures supplied by the filament vendor. If you can't get them, use the figures supplied in the generic presets in Bambu Studio for that material type and adjust them if you need to based on performance. The same applies to the print temperature settings here. Use the temperatures recommended by the vendor, but if you can't access them, use the generic preset for that material type and adjust as needed. We have one last setting in the filament tab here, volumetric speed limitation. This is used so when you are doing things like switching to sport or ludicrous mode, or just setting a very fast print speed in your process settings, it knows what's the absolute fastest this material is able to be printed at, effectively based on how quickly it's able to become molten. This figure should be supplied by the vendor for this specific material, but as with all these settings, if you can't find a vendor-specific value, just use the default for the generic preset of this material type in Bambu Studio. In the cooling tab, most of these options and settings were already available without the advanced switch activated, so if you need to know about these, check out my Bambu Studio beginner's tutorial. We do, however, have a couple of new settings here. The first is minimum print speed. Now, this is related to the tick box above, which I didn't really cover in my basics tutorial. With the slow printing down for better layer cooling box ticked, if the layer is shorter, as in it'll take less time, then your minimum layer time threshold is set to, whilst your fan is at the maximum speed threshold, it will slow down your print to improve layer cooling of that layer. Your minimum print speed setting here is the slowest it will be able to slow the print down to on those layers. The tick box beneath was also available without the advanced switch turned on, but just forces cooling for overhangs and bridges, which are areas you'd want the extrusion to cool and solidify as quickly as possible, as there isn't a layer beneath it that you want it to remain hot enough to bond to, and you want to cool it down and solidify it as quickly as possible to reduce sag. The cooling overhang threshold is, if you'll excuse the pun, a cool setting. If you imagine your extrusions are, as they are, single lines, if you were printing directly on top of a line below, and they were perfectly aligned, that would technically be 0 here. Whereas if it was 0.4 millimeters to the side of the extrusion below, or whatever the width is of the nozzle that you're extruding from, then it would be 100%. Effectively, this setting allows you to set what is considered an overhang for these cooling needs. By default, it's set to 50%, which means providing the current extrusion is at least half off of the layer below it, then activate the overhang cooling. This is the speed that the fan will switch to when overhang cooling is activated. The auxiliary part cooling fan is referring to a fan specifically found in the Bambu Labs X1C, which is the printer I've got selected. All FDM printers have part cooling fans located around the nozzle, blowing down on the newly extruded filament to try and cool it down as quickly as possible. The Bambu Labs X1C has an additional fan located on the inside left of the enclosure, which blows a stream of air over at this level, at the extrusion level, to further try and cool it down as quickly as possible. With some prints and some materials, this can really help, but with other prints and other materials, it can also be quite detrimental, so you'll want to experiment with this if you have an X1C to figure out the best settings for you and your print. All the fan speeds and settings are going to vary depending on the material you're printing with. Some materials need maximum cooling as much as possible, whereas others prefer minimum cooling or none at all. For the most part, unless you experience issues in your prints, the settings in the cooling tab here can generally be left as the default for that material type. Under the Settings Override tab, we've got a list of settings under the Retraction heading, and these may look familiar because they're the same settings we saw in the Printer Settings section. The difference is, if you have any of these settings ticked and selected, when this filament preset is applied to a filament that you're using, these retraction settings will be used instead of the ones that you have set in the printer settings. And finally, we have the new Advanced tab split into Filament Start G-code and Filament End G-code. Here you can enter G-code scripts, which will automatically be run anytime the filament which this is a preset for is starting or ending a single use. Finally, we'll look through the process settings with the advanced switch turned on. This is split into 5 tabs: Quality, Strength, Speed, Support, and Others. First up, we have the Quality tab. Whilst layer height has no changes or additions, we have several new categories here, the first of which is line width. This is referring to how wide the line is you're printing after it's been extruded. The filament will likely expand very slightly on the outside of the nozzle as it's pushed up against the filament that it was extruded just before it and has already started to cool. By default, for a 0.4mm nozzle, the line width is set to 0.42mm. The first layer, or initial layer, has a separate line width setting, and this is by default set to a slightly thicker width than that of the default line width. This is for a number of reasons, but primarily for bed adhesion. You then have a variety of settings to change the line width for all of the line types. This whole section will normally be fine to be left on default, but this is something you can adjust if you're finding you're getting under or over extrusion issues. Below that you have seam, which I covered in the basics tutorial, but effectively is a drop-down menu where you can select your preferred default for the position of the seam if you haven't used the seam paint tool. Next we have the precision section. Your slicer will automatically fill in any gaps in the model which are smaller than twice the closing radius which you've set here in the slice gap closing radius section. So if you set this to 0.05mm, it will close any gaps in the mesh which have a diameter of 0.1mm or smaller. Whilst this can repair imperfections, it can also reduce the resolution of your print. So, as the tooltip in Bambu Studio suggests, try to keep this figure as small as possible. Really, this should only be something you need to change when troubleshooting, and I don't think I've personally ever found I've needed to adjust this from the stock 0.049mm. Resolution is, as it sounds, the resolution of your print, but specifically it's the resolution in the X and the Y axis. In the Z axis, the resolution of your print is controlled by the layer height, but in the X and Y, whilst it will absolutely be affected by the nozzle size that you have fitted, you can further adjust the resolution of your print here. Whilst an extrusion will usually be 0.42mm or whatever you have set under your line widths, the actual path of the extrusion can involve following a route significantly smaller than that. When you slice your design, any lines between 2 points that is smaller than the length that you've entered here will be simplified to this length to reduce the amount of commands needed to be produced in your G-code file. This makes it much faster to slice as it's not generating command lines for movements that would be imperceivable or even detrimental to your print. Arc fitting is a really cool feature which can both speed up your print and in many cases improve the quality, or at least it would do if it wasn't for the fact that you were probably already using it, because usually this is set by default to on. When the model you're using was exported as an STL, the model was converted into a collection of triangles. There may be 12 if it's a simple cube, there may be hundreds of thousands, but regardless of the complexity of the model, it's constructed out of a collection of flat-sided triangles. With a flat-sided model, this makes sense, but if your model features any sort of curve, that curve is then made of dozens of triangles, each one at a slight angle from the last, which when put together creates the impression of a curve. However, when a curve like this is sliced, the toolpath is then following this path, making a series of very small straight lines. Not only does this result in a long list of commands in the G-code file, it can also take longer to actively print, make more noise, and depending on the resolution of your print, can reduce the quality of the curved edges. Having arc fitting enabled tells the slicer to look at the areas where curves are created by flat triangles like this, then it figures out a constant curved line that flows through each of these points. This requires printers recognizing G2 and G3 moves, which most new printers do, and then it creates a toolpath specifically following this new genuinely curved line. It means that even though the curves in your STL are made of a series of flat shapes, the final print will be a true curved line. The XY hole and contour compensation settings are good to use if you're having issues with the tolerance of parts of your print. If on the whole the prints are coming out at the right dimensions you want, but certain holes or shapes which are used to slot things together are coming out too tight or too loose, you can adjust the settings here, and it will grow or shrink these holes or contours by the amount that you've set here without adjusting the rest of the measurements. In 3D printing, elephant foot refers to when the bottom layer of a print is squished out, sort of like the shape of an elephant's foot. This can happen for a number of reasons and is more common with some filaments than others, but is easily solved using this compensatory function. Adjust the figure here. By default it's set to 0.15mm, and it will shrink the perimeter of the first layer by this amount, so as it expands it then matches the size of the rest of your print rather than sticking out to the sides. Next we have ironing. I'm going to be releasing a video looking more closely at this very soon, and no, this is not an automation for housework. Effectively what ironing does is once it's finished printing a top layer, which is any flat area which doesn't have something that will be printed on top of it in the next layer, it then passes a hot nozzle over that area, melting it more into each other and effectively ironing out the visible extrusion lines. You can apply this to all top surfaces of the model. You could apply it to just the very topmost surface, so with a benchy this would be the top of the chimney and wouldn't include things like the deck. Or you can apply it to all solid layers. Once you've turned ironing on by selecting what area you want ironed, you can then select the pattern it will iron it with, along with the speed, the amount of filament it extrudes whilst ironing, and how far apart each part of the ironing will be. So this is the space between each line that is going to pass. You'll want to adjust each of these settings to meet your needs, but the outcome will be different depending on the model you're printing, and your printer and the filament you're using. Remember, ironing will only ever be applied to the top of the layers and won't apply to the sides of the model, therefore it won't affect layer lines. If there's an area of your model that you want this to be applied to, you'll want to orient it in your slicer so that side is facing up and perfectly flat. Below that we have Wool Generator, and here you have two options: Classic, which is set to by default, and Arachne, which then gives you a list of other settings. Again, I'll be doing a deep dive looking into Arachne and wool generation in general in a future video, but for now, let's have a look at what this means and what these settings do. Effectively, the difference here is how thick wools are of your print. With Classic selected, the wools are always set to the same thickness, and for very thin areas between wools, it will use gap fill where possible. With Arachne, however, it will vary the width of the wool extrusions based on the thickness of the area in the model. This can result in better performance when needed, but personally I tend to leave it on Classic at the moment. That said, I definitely think as I spend more time with it, I'm going to end up becoming more of an Arachne convert. When you have it selected, the first option is the transitioning threshold angle. This will determine if it should fill in the gap between two wools that are converging depending on the size of the angle. The transitioning filter helps prevent it from constantly jumping between different amounts of wools. Consistency is important with the structure of 3D printing, so this is a good figure to play with when getting used to Arachne wools. The transition length is what it sounds like. This is the distance allowed for it to transition from one wool thickness to the next, based on a percentage of your nozzle diameter. The wool distribution count is also quite an important one. This is basically saying of all the wools on that perimeter, how many can it apply the varying width to when making the necessary changes. So as it currently is set to 1, this would only use the innermost wool. If I had my wool count set to 3 and I set this to 2, it would then use the inner 2 most wools. The key thing here is to ensure that it is not going to affect the exterior perimeter, as that could then affect the exterior size of your model. The higher the number you have selected here, the more likely it will affect the exterior wool, even if that wool isn't one of the ones that this setting is being applied to. You then also get control over how small the wools can be, and the minimum thickness of a feature of your model for this to take effect. I know I blew through that quite quickly, but Arachne wools can be quite a lot to cover, so as a reminder I am going to be publishing a more specific video on them, and we'll be going through some visual examples with that too. The final section we have in the Quality tab is Advanced, and the first setting we have in this section is Order of Wools, which is as it sounds. This allows you to choose whether you print the external wools first or the internal wools first. By default, it will print the inner wools first. This can be good as it lays the foundations for the shape it's printing, especially on the first layer, and means that when you get round to printing the external wools, which are the ones you're going to actually see when the print is finished, it has something for them to fuse to and hold it in position. For some models, you may prefer to print the exterior or outer walls first, and for some people this is a preference just to leave it set to this for default. This is then going to print the exterior walls or the outer walls first, followed by the inner walls, and then finally the infill. There is also the option to print the innermost wall first, followed by the outer wall, and then, providing you've got 3 or more walls set in your wall count, any walls in between. There are a number of reasons you would want to change the order of the wall printing, but it does depend on a print-by-print basis and just a personal preference. By default, it will print the walls of each layer before it prints the infill, but in the interest of giving you as much control over the print as possible, here you can request that the infill for each layer is printed before the walls. The bridge flow refers to the amount of material extruded when bridging. By standard, depending on other settings that you've set elsewhere, the temperature and print speed may be adjusted when printing bridges, but the same amount of material is still being extruded. Here you can reduce it slightly, effectively making the weight of that bridge lighter and therefore possibly reducing the sag of that bridge at the expense of slight under-extrusion for that layer. The figure you enter here is based on the standard extrusion amount, so 1 equals 100% of the standard extrusion amount. Set it to 0.9, and it would extrude 90% of the normal extrusion amount when printing bridges. The thick bridges setting sort of does the opposite. Whilst reducing extrusion can reduce sag and therefore improve the overall appearance of bridges, if the bridge is particularly long, it may just snap and fall apart completely. One way to get around that is to tick this box, which increases the extrusion for bridges. This will allow longer bridges to be successful, but at the expense of increasing the amount of sag in them. Despite being in an advanced section, the only one wall on top surfaces is a feature that was available without the advanced switch turned on, and so I have covered this closely in the Bambu Studio Beginner's Guide, but effectively this allows you to set it so regardless of how many walls you have set, on the top surfaces or topmost surface, there will only be one wall, allowing the top surface infill to span the width of the layer. Equally, the only one wall on first layer setting was also available beforehand, and this is pretty much the same thing, but applies to the first layer on the bottom of your print. The final option in the Quality tab is Avoid Crossing the Wall. This can be really useful, especially if you're experiencing stringing or blobbing and have done everything else you can to reduce it. If you have this ticked, it will try to avoid making toolpaths that cause the toolhead to cross any exterior walls when moving to another section. The blue lines here show the travel paths. This is the movement that the nozzle will be making in areas where it's not actively extruding. If retraction settings aren't spot on, or if your filament isn't playing ball, you can find that thin strands or strings can be accidentally printed when the nozzle follows these paths. With this feature turned on, it tries to avoid travel paths which involve crossing over exterior walls as much as possible, as if stringing occurs within the exterior walls, you're never going to see it once the print is finished. Whilst this can help with stringing and blobbing, it can also massively increase the print time, as the nozzle is then going to be following longer paths to get where it's going without crossing the wall where possible. As a result, when you've got it turned on, it also gives you the option to set the maximum detour it can make from the move it was originally going to do, either in millimeters or a % of that move length, to try and limit how much time it adds. Okay, so that's the end of the advanced settings in the Quality tab. Let's flip over to the Strength tab and have a look in there. Quite a few of these settings were available without the advanced switch turned on, so were covered in my beginner's guide, but there's also a good number of new ones. The first of which is Detect Thin Wall. Whilst wall loops is the number of walls it aims to draw around the perimeter of the model, this detects areas that are too thin to contain 2 line widths, as 2 lines would be the minimum requirement for an exterior wall either side of that section of your model, and when detected, will just print a single line. Remember, this is line widths as you've got set in your Quality tab and not the diameter of your fitted nozzle. It can be useful if you want to print particularly thin areas acting as, for example, windows, but can reduce quality, so generally you're likely to leave this unticked. With it unticked, it just won't draw these areas at all. It's worth noting that this will be grayed out and unavailable if you have Arachne walls selected in the Quality tab. The whole of the top-bottom shells section is covered in my beginner's tutorial. Sparse Infill, however, has a couple of additional settings now. Length of sparse infill anchor refers to the points at which infill connects with the interior wall, the anchor. The length refers to the length that the infill, when it connects to the inside wall, will follow that path to aid with adhesion. It's currently set to 400% of the line width, but if I set it to 0, you can see that the entire anchor disappears. You can set this both in millimeters or as a percentage of the line width. The maximum length of sparse infill anchor is another metric for the same mechanic and sets the maximum size that each anchor with its increased size can be. Unlike the Quality tab, which had a couple of advanced features even without the advanced switch flicked on, Strength has gained a whole new subsection of features, the first of which is infill wall overlap. This is different to the infill anchors, which adjust the length of the infill will follow the path of the inner wall. Infill wall overlap refers to how much an infill line overlaps with the inner wall to effectively bond with them. Set a percentage of the line width that you've set for the sparse infill. The infill direction refers to the angle that the pattern is printed at relative to the print bed, not the model. By default, it's set to 45 degrees, so if I slice this now with a grid infill, you can see that the grid is lined up at a 45-degree angle across the bed. If I switch this to 0 and reslice, you can see that the grid is now aligned with the X and Y axis. The bridge direction is very similar, but refers to the bottom surface infill of a bridge, which can be good to adjust so that the infill is primarily fusing with the solid structure lines and not just the bridged perimeters. The minimum sparse infill threshold allows you to set an area in millimeters squared, where if there's a space smaller than you've set, instead of the infill percentage that you've set for the main model, it'll just use solid infill. This is really good if you're using a pattern which is good for most of your model but doesn't scale well or work for confined spaces. If, for example, you're using gyroid, which is my preferred infill pattern where suitable, at a low infill percentage, it just can't form a decent structure if the area is too small, so this can help there. Infill combination is a time-saving mechanic. It basically combines several layers of infill and prints them together as deeper extrusion lines, whilst printing your exterior perimeters at the layer height you've set. So let's say you had your layer height set to 0.2mm. Normally, your infill would also be printed in 0.2mm layers with the rest of your print. With this activated, however, whilst the walls are still printed at 0.2mm, the infill is only printed every 2 exterior layers, meaning that the infill is being printed at roughly 0.4mm layer height. This absolutely saves time as it's not printing infill every layer, but it may affect quality in some cases and won't allow you to print the infill as quick if you're already using a particularly thick layer height, as it's going to need to melt and extrude much more filament much faster. I'd suggest only using this if you really need to save time. Detect narrow internal solid infill basically looks for areas where solid infill would be used but is particularly narrow. By default, solid infill is printed with a rectilinear pattern, and in really small areas, it could be challenging to effectively print this pattern, and results in lots of additional toolpaths being created. With this ticked, it finds those areas and uses a concentric solid infill pattern, which is more suitable for narrow areas. When printing a sloped surface, if you've got your wall count set to say just 2 walls, depending on your line width and the angle of the slope, it could mean that on your sloped surface, the thickness at points between the internal wall and the outside of your print is potentially even thinner than you've set for your wall thickness, let alone your top shells. With the Ensure Vertical Shell Thickness box ticked, it will add solid infill to the inside of the sloped surfaces where needed to ensure the effective wall thickness is at least equal to the shell thickness you set in the top-bottom shells section above. Finally, in the Strength tab, we have the internal bridge support thickness. This effectively prints permanent support material where required inside your model, so within the walls that you're never going to see after it's printed, and helps provide support for internal bridges being printed within your model. The figure you set here determines how thick the diameter is of the support material, which is printed in loops. If you set this to 0, it will turn this feature off completely. Okay, so that's the Strength tab ticked off. Now to move on to speed. If you're new to the advanced features, which you probably are if you're watching this video, this entire tab will be new to you, as without the advanced switch turned on, you have no speed controls here at all. First of all, we have settings for the initial layer speed. This is divided into two speeds, a speed for the infill and a speed for every other part of the print. Both of these are only applied to the very first layer of the print, and you'll always want to print nice and slow for the first layer to ensure decent bed adhesion. When you slice your model, if you go up to the color scheme and change it to speed, you'll be able to see what speed different parts of your print are being printed at. With the model sliced, if you change the color scheme to speed, you can see what speed each part of your print is being printed at. The infill here is being printed at the 105mm a second that we've got set, but you can see that the perimeter, the wall, is being printed significantly slower. Even though we've got it set to 50mm a second, it's more like 10 to 15, and this will partially be because of the small perimeter settings that we're going to look at in a minute. Now we have the speed options for the different extrusion types for the rest of the print from layers 2 and up. This allows you to set the print speed for your outer walls, your inner walls, your infill, etc. Now, this is going to depend on what you're printing, the material you're printing with, and the performance you're after. It's also worth noting that the theoretical speed limits are different depending on your layer height. Your printer can only successfully heat up and push out X amount of filament per second, depending on your printer and the material. If you're printing at a 0.2mm layer height, your extrusion will require twice the volume of material per second as if you were printing at the layer height of 0.1mm. As a result, depending on the variables at play, such as your printer, the material you're using, and your existing settings, you may want to print slower at thicker layer heights. So counterintuitively, the printer can actually print faster at thinner layer heights, but the print will still take longer overall as it has more layers to do. With this in mind though, it's important to check your speeds if you're using a settings preset and you manually increase the layer height. You'll want to check that the speeds in that preset are suitable for the layer height you're using. It's also worth noting that whilst printers like those by Bambu can print exceptionally fast compared to the 40 to 60mm a second of the old standard, even if the material you're using is capable of printing at these speeds, it can affect the surface texture, with people often surprised by the normally shiny prints now looking rough or matte. If you're having that issue, try slowing down just the outer wall speed, as that is the section of the print you're going to see and won't significantly impact the overall speed of your print. I often have my outer wall set to more like 40mm a second, even if I have other speeds at 200 to 400mm a second. Another issue with printing too fast is that if you're printing a particularly small area, the layer below it may not have yet cooled down enough to solidify, which means as you're printing on top of it, you end up moving it around and it might cause a complete failure. The small perimeters setting can be used to avoid this while still printing at fast speeds. Here it will detect small areas with a perimeter smaller than what you've set in the small perimeter threshold, and it will then print those areas at the speed you've set in the small perimeter section. You can either set an absolute speed, or you can set a percentage of your outer wall speed that you've set above. As well as being able to set the absolute speeds for different print elements, you can also tick this box, which causes it to slow down a bit when printing overhangs. With this ticked, it gives you the option to set the speeds for different degrees of overhang, effectively how much the layer is overhanging over the layer below based on a percentage of the line width. 10% overhang would mean the current extrusion has 10% of the line width hanging over the edge of the layer below. Those are the speeds that the printer will use when actively printing different parts, but as we saw earlier, the printer will also need to move when it's not actively extruding filaments. The next setting we have is travel speed. This is the speed the printer can move at when it's not actively extruding. It can obviously move much faster when it's not printing, as it doesn't need to be able to melt and extrude filament to keep up with those speeds. However, the faster it goes, the more vibrations it will create and the bigger potential for lower accuracy in the print. If your printer is listed in the configuration wizard when you first set up Bambu Studio, rather than having to enter all the specs for your printer manually, this is likely set to a decent speed that your printer is capable of without affecting quality, so generally it can be left as it is. Below this, we have the last section of settings under the Speed tab, and that is acceleration. Acceleration is as it sounds. It is the rate at which a printer can change the speed that it's running at. Over the past few years, acceleration has been recognized as a very important element to what is allowing printing to speed up without affecting quality. Before acceleration was a real consideration for printing, printers would tend to jump to very fast speeds too quickly and cause print quality problems. But with these settings dialed in, it allows you to print at high speed with good quality still. I plan to do a deep dive into acceleration speeds in a future video where we can really look at what each of these does, but for most of you, you won't need to worry about this and can generally leave them as they are. When you feel particularly confident in 3D printing, if you're in the mood to experiment, this can be a good place to try and make very fine tweaks to further improve the speed and performance of your printer. And that's it for speed. We now have the penultimate tab in the process settings, support. We already covered what support material is in the beginner's tutorial, but there are a few new settings here. Just as a reminder, support material is effectively the scaffolding that you can print to support areas of your model which would otherwise just be printing in mid-air. Under type, you can select between normal and tree-shaped support material. Each have their own pros and cons, but as a rule of thumb, normal is better for large, wide spaces, and tree is better for lots of small details. You can see here that even though I have tree selected, it has created both tree and normal support. I'll talk about that more in a minute. You can also choose between auto and manual. Auto will automatically generate support material anywhere it thinks it needs it, unless you have blocked it. Manual, on the other hand, requires you to go into the support paint tool and select areas you specifically want there to be support. I've just selected 2 areas that I want support here, so let's go into manual mode, slice it, and then you can see it's only supporting those 2 areas which I painted requesting support. It's not supporting the other areas which would otherwise need it. The first new option we have is style. The options you have under style will depend on the support material you have selected. With normal selected, you'll be able to choose between grid and snug. Grid support material will print with a wider grid-like base to the supports and generally is much more stable. However, it can use quite a lot of filament and take quite a lot of time. Snug, on the other hand, tries to make the support material structure as slimline as possible, reducing time and material usage, but can make it less stable. If, however, you have the tree support selected, you've got a few different options. There is Tree Slim, which is the first one, and with this sliced, it will just create thin, tall trees. This can be quicker and more agile getting around different shapes of your print, easier to remove, for example. Tree Strong will give you thicker bases. They merge more into the base of the trunk. This can make them much more strong and stable, but it will take more material and more time to print. The next option is Tree Hybrid, and this is the one that is set as default. You can see that it has used tree support in the smaller areas and normal support material in the wider areas. Finally, there is Tree Organic. This is like a mix of Tree Slim and Tree Strong. It bears more of the design style of Slim by having more traditional tree shapes with single trunks and then branching up coming off of that, whilst it uses much thicker trunks than that of Slim, making a stronger support option. I touched on the threshold angle in my basics tutorial, but it's basically the angle at which a surface needs to be below in order for supports to be generated for it when you've got one of the auto support modes selected. On-build plate only was also covered before, but simply stops support material being generated on top of the print. With this ticked, all support material must have its foundations printed directly on the build plate. Support critical regions only allows you to use the auto support option whilst avoiding lots of unnecessary support material and just using it where the slicer thinks it's absolutely necessary. Remove small overhangs is a useful one to leave ticked most of the time. If you're using an auto support type, this will avoid support anywhere you have a very slim overhang that would likely be fine without support material. Without this ticked, you could end up having support material all over your model even where you don't really need it. Next we have rafts. Now rafts aren't used as often as they used to be and tend to be for very specific models, problematic materials, or misbehaving build plates. Effectively, a raft prints, as it sounds, a raft of extra thick extrusions directly on the bed, lifting the entire of your model up, and therefore the model is printed on top of that and not the print plate. It's sort of like a more sturdy support material that goes under your entire model, not just the overhangs. It can be good if your model needs to be printed in a specific orientation, but in that orientation there's extremely small contact points with the bed. With raft layers set to anything other than 0, you'll get 3 new options. On the topic of raft layers, if you do need to use a raft, I suggest setting this to 2 or 3. If you set it to 1, then only the raft interface layer will be printed. The raft contact Z distance is the distance between the top of the raft and the bottom of your print. The bigger the gap here, the less likely your print to fuse with the raft, but the more likely it will become misshapen and possibly fail because it's effectively printing in mid-air. Think of the initial layer density as the percentage infill of the first layer of a raft, so the higher number you have here, the denser this first layer will be. And lastly, in raft, we have the initial layer expansion. As I say, these layers are particularly thick so as to ensure that any imperfections in your bed are filled out with these layers. The thicker this setting, the thicker the raft. We'll skip over the filament for supports, which I covered in the basics tutorial, but this is where you can set to use a different material to print your support materials or the support material interface so they're easier to remove. There's quite a few settings under the advanced section, and what's shown here is going to depend on what type of support material you have selected. So let's start out looking at the advanced options for normal support. First up is support wall loops, which adds a perimeter wall around the outside of the support material. The main purpose of this is to make it stronger and more stable. If you're finding that your support isn't holding its structure well enough, this may be what you need to solve that issue. It's worth noting, however, that if you have wall loops added, of which you would only ever need one wall, it can make it more difficult to remove them. Next up is the top Z distance, and this is the distance from the top of the support interface layer to the bottom of the model where it's supporting. This is basically the same as the raft contact Z distance that we looked at earlier with the raft. The bottom Z distance is the same concept, but it's for support material that is printed on top of the model. So this would be from the top of the model to the bottom of the bottom interface. The base pattern is the pattern that the main support structure is printed in. As standard, this is a rectilinear design, but you can change this to a few other patterns, including honeycomb, to add extra support or strength, but generally you're fine leaving this as default. Base pattern spacing is the spacing between the support lines. A larger number here is going to provide a larger space between them, therefore speeding up the print and reducing the material usage, but it could mean the support material is less stable. Think of pattern angle as the same as sparse infill angle. It's the same thing but applied to the structure of the support material. So if we set this to 45 degrees, it will then match the angle of the infill, which we've got set to 45 degrees. The interface layers are the layers represented by thick dark green lines once sliced, and are printed in between the support base and the model. They are what provides a flat and more even surface for your model to print on top of. With the scaffolding analogy, if the support base is the scaffolding poles, the interface is the wooden planks laid across the top. The bottom interface layers are the same thing but printed between the model and the support material when the support is printed on top of the model. Here you can select how many interface layers there are applied for both top and bottom interfaces. The interface pattern is the pattern used for the interface. Generally leave this as default, it works well with the support base. And here you can select the top interface spacing, which is how far apart the top interface lines are drawn. The normal support expansion is an interesting setting where you can set an amount of the interface to grow or shrink from the horizontal expanse of the surface it is supporting beyond the normal supported scale. Here, with it set to 8mm, it is now expanding the support material 8mm beyond the area that it's going to support. The support object XY distance is the minimum distance the support material can be printed to your model in the XY axis. So this isn't referring to the distance between the support material and the section of your model that it's supporting. It's referring to the distance between your support material and the side of your print it's growing up next to reach the point which it will be supporting higher up. If you find your support material is fusing with the side of your model, this is the setting that you would want to change. By ticking "Don't support bridges," it prevents support material being automatically generated beneath bridging areas. The independent support layer height is similar to the infill combination setting we looked at earlier in the Strength tab. It allows the support material to be printed with deeper extrusions, meaning the support material may only be printed every 4 layers of your model, but by printing deeper lines of the support material, it can print directly on top of the previous printed layers without having to print your actual model at a deeper layer height. This saves time in printing supports. Now let's look at the advanced settings available with tree support selected. Bear in mind, some of these settings are only going to apply to normal style supports, which are generated when you've got tree hybrid selected. The tree support branch distance is the minimum distance that must be maintained between tree branches. This helps ensure that supports don't fuse with each other in awkward places and therefore remain easy to remove, but also that they don't interfere with each other and cause issues with the print. With the tree support branch diameter, you can actually set the target size for the support branches. By the nature of their design, tree support branches are overhangs sticking out at an angle. With the tree support branch angle setting, you can set the maximum angle they're able to be overhung by. As standard, all of these settings usually work fine, so only adjust these if you're having issues. The next setting that we've not seen yet is the tree support brim width, which allows you to increase the brim around the trees to improve bed adhesion if you're having any issues with it. 0 will set it automatically depending on its height and overhang distance, but you can also set it as an absolute distance, which will then be applied to all of the tree support bases on the plate. The final advanced setting that's specific to tree support is maximum bridge length. Whereas with normal support, you could just select to avoid supporting bridges altogether, with tree supports, you can select the maximum length a bridge can be before it automatically applies support material. And with all the support settings done, let's turn off supports for the rest of this tutorial and go to the final tab, Others. I covered brims and skirts in my basic tutorial, but we get one new feature here. As a reminder, a brim is effectively loops printed around the perimeter of the model that help improve bed adhesion by giving it a bigger footprint. This extra feature we gain now is brim object gap. This is the distance that the brim is printed from your model. You want it to be close enough that it fuses a bit, otherwise it's not going to hold down your model, but you can slightly increase the distance here if you're finding that you're not able to easily remove the brim after printing. This distance can vary depending on the design you're printing and the material you're using. We also get a new setting under the prime tower, allowing us to manually select the width of the brim specifically for the prime tower. So this can be good if you're using a particularly thin prime tower and you want to add some stability. Down under special mode, we have slicing mode. Now, 99.99% of the time, you'll want to leave this as regular, but under very specific scenarios, you have 2 other options you may want to switch to. Even odd has been included specifically for when printing 3D lab print aeroplane models. These models were specifically designed to be sliced with Simplify 3D, which is another slicing software, and this slicing mode tries to emulate the style in which they'd be expected to be sliced. The other is close holes, which will cause the slicer to try and automatically fill in all internal structures in the model. Again, except in very specific circumstances, you're never going to change the slicing mode from regular. The other settings in special mode I already covered in my basics tutorial, but I wanted to look a bit more at the print sequence. By standard, this is set to by layer. So what that means is if you've got multiple models on your print bed, when you've sliced it, it will print them both at the same time. So it's going to print the first layer of one, then the first layer of the next, then move up to the second layer of one, and the second layer of the next, moving up, printing both models at the same time. The alternative is by object. This is slightly different. It gives you a barrier and you need to make sure that the objects are not conflicting these external barriers. This is basically the area that the print head is going to move around these to try and print the model. Once you've sliced it, you'll see that it is printing one model and then the next. Generally, the only time you're going to be using print by object is with certain materials where moving between them would cause issues such as stringing, which can be an issue with materials such as TPU, but for me, I would personally just rather print them as two separate prints rather than risking a print head collision. Now I want to jump down to the advanced section and look at the interlocking depth of a segmented region. This is an interesting and little known feature which comes into play when doing a multi-material print. Normally, an area painted in a different color here will have a section feeding into the model, all of which is the same color. On rare occasions, specifically if you're using a different material type rather than just a different color, you may find that this area hasn't fused properly with the rest of the model, and as a result, it may not remain in place after printing. By adding something like 1 to 2 millimeters here, you can effectively add locking bars with the dominant color running across these areas of a different material or color, and therefore holding them in place. Next, we have reduce infill retraction. This prevents retraction when printing infill, specifically when the head is moving within the infill area. As a result, any oozing or stringing in this area wouldn't have any effect on the outside quality of your print and may slightly speed up the print itself. However, it requires the slicer to figure out all the times this would happen and the best routes to take, which may result in the slice taking much longer to process. This is turned on by default, so if you're finding that your computer is really struggling with slicing and it's taking a long time, try turning this off and see if it speeds things up for you. And finally, we have post-processing scripts. Here you can add custom scripts that the G-code will be run through after being generated by the slicer, but before being exported. This can be good if you want to make specific command tweaks or if you want to do something a bit more full-on. Well, that's all the features which get added to Bambu Studio when you activate advanced mode. I will, as I've said, be doing deep dives into a lot of these features in future videos, so do keep an eye out for them. But for now, you are officially a Bambu Studio advanced user. So give yourself a pat on the back, top up that well-earned coffee, and it's time to get printing. Now that you're an expert, why not check out some of my own 3D printing projects which I've covered in the past, or check out some of my other tutorials which look at specific features. While you're at it, don't forget to like and subscribe. It makes a huge difference to me. Thanks very much, guys, and happy printing.